Good afternoon, dear ladies and gentlemen. My name is Okulov Roman. I present to your attention the scientific work entitled Mathematical Model of Process of the Plasma Atomization of the root electrode to produce titanium powder. The development of additive technologies has led to increase in the demand for metal powder. As raw metal for 3D printers, powders with fraction size in range 20 to 100 micrometer from allows based on titanium, copper, and stainless steel are used. In connection with this, the development of technology is required to produce powder with desired properties on production scale. One of actively developing in applied methods for producing metal powder is technology of plasma pulverization and metal route. An installation was developed in the remote laboratory of the rural branch of the Russian Academy of Science that allows the production of the metal powder by plasma atomization. As a result, an operation of equipment for production of powder, the effect of sticking of a powder particle on internal surface of the reactor was manifested. In order to avoid the phenomenon, we create a mathematical model that adequately describes the real processing in order to predict and control process of powder production. The monitor shows the calculation area with grid the narrow ways and in place very high accuracy we required area with increased density and smaller smack size were used. The element size selected at which sufficient accurately and exactly volume time spent calculation at this computer show the use computer are ensured. In this article, a tolerance measurement of the average temperature volume of ±2 Kelvin was accepted. The following were taken in input data for calculation. Gas type is argon. Gas volumetric rate is 15 liters in minute. Plasma forming gas pressure 1.5 atmosphere. The plasma temperature is 7000 Kelvin. Figures 5 show what is cross section. The maximum volume of temperature of plasma jet is reached when approaching the flow X. The results are presented in Table 1 and Figure 6. As a result, we analysis of data present, it was concluded that what is more efficient of use a second type reactor. In order to verify the result of part and mathematical experiment, we conducted a full-scale experiment. The purpose of the full-scale experiment was determine temperature of the plasma jet. Allowed this act of the subsequently comparison of the obtained data with results of computer experiment. For this route, with a diameter of 3 mm were selected from materials with different metal melting points. The rods were alternately placed in manipulator perpendicular of the axis and plasma jet flow, so that one end of the root was the X of the other was clamped of manipulator. The manipulator was located in distance of the half meter from the plasmatron. Next, the manipulator with the root mounted in it, the gradually moved in the constant speed 50 mm per minute, parallel of axis of the plasma flow toward the plasmatron. The distance from the root, the end length of the anode was recovered. The optical parameter was used, which recovered the surface temperature of the free end of the root. In moment then, melting began on the surface of the root. Data were taken from the photometer scale, and a distance from root to plasmatron was recorded. Figure 8 shows the overall on the theoretical curve on the data obtained from full-scale experiment. The result of comparative analysis shows satisfactory convergence. 5 aspects should be noted as a main result. Thank you for your attention.